Okay, I'm sorry we got cut off on that last video. So let me get back to where we were. So we said that the professor here is going to fire a ball sideways. And when he does that, the ball is going to basically fall, the same distance as the ball that was just dropped straight down. And the point that I was next going to make was that if you looked at the velocities, the vertical velocities of this ball that's falling, what would those be? How would those compare to these red vertical velocities for the dropped ball? And the answer is that those velocities would be just the same. They have to be, because gravity is causing free fall to happen in the vertical direction. So, if you're going to sketch the velocity vectors for a projectile, really, at 1 second, the vertical velocity is 10 meters per second going down. At 2 seconds, it's 20 meters per second. At 3 seconds, it's 30, etc., etc. It's that simple. Now, what about the other direction? What about the horizontal component? Well, if Honeydew shoots the ball with a certain velocity horizontally, maybe it's 10 meters per second, right? It's going to keep that 10 meters per second forever and ever. And so that green vector is just always going to be the same. Okay? And so sketching that component is very easy. Now, if you want to sketch the overall resultant velocity, hopefully you know what to do. You're going to box in these vectors, the pairs, or rectangle them in, and then you can sketch the resultant by drawing it from the corner of the box out to the outer corner. And if you're careful with your drawing to make sure that resultant goes to the outside corner, you are going to get an accurate picture of the velocity of the projectile as it's falling. And hopefully you'll see something which is growing in magnitude and which is also getting steeper. I'm not going to do this. I'll leave it as an exercise for you, but you should be able to calculate the magnitude of that resultant vector, and you should also be able to calculate its angle. And the angle that we'll talk about is the angle basically below horizontal. So my cursor is trying to show it right there. So a couple things just to summarize on the side here. How did we find the red vector values? Basically, to calculate Vy, you just do G times T. 10, 20, 30, etc. How do we determine the green vectors? Well, all we need to know is the original vector, the original velocity, and that stays the same. And then how do you find the black vectors, at least their magnitudes? You would use the Pythagorean Theorem. Okay. So this little table down here kind of lists the values. Vx is always equal to 10, and Vy is going to be changing in that sort of a way. And I'm going to leave the rest of the math to you guys to practice with. I think that is kind of the end of our lesson here. And let me see. So what should you be able to do now? Given the initial speed of a horizontally launched projectile, you should be able to predict its x and y components at any time t. That's kind of what we just did in the last slide. You should also be able to calculate the magnitude and the angle of the total velocity vector at each time using the Pythagorean Theorem and the inverse tangent function. And that goes back to lesson number 2 from today. So for the rest of the time here, I'd like you to start practicing some of these skills. There's a packet that you can work in. And you can, of course, check your answers to the packet by going online and check them as you work. Probably the best thing is to work with a partner and to help each other out as you go. All right, and I will see you soon. Oh, I was going to say one more thing. Just as a little plug here, I wanted to make sure that if you are struggling with this, especially in my absence, and you'd like some more resources, you can, of course, go to the physics classroom. And the section on motion and forces in 2 dimensions has excellent materials on what we've done today. So especially lessons 1 and 2, they're pretty self-describing in terms of their titles. So some of these are related to what we're doing, some of them aren't. But definitely I would reference you to those. And there's a link on our webpage today. Okay, thanks, bye.